The images released by Iranian state media 72 hours ago represent the most significant shift in naval balance of power in the Persian Gulf since the United States established permanent carrier presence in the region following the Iranian Revolution in 1979. What the Islamic Revolutionary Guard Corps Navy unveiled during carefully choreographed ceremonies at Bandar Abbas Naval Base was not a prototype demonstration or a symbolic capability display. What was revealed to the world through high-resolution satellite imagery, underwater acoustic signatures captured by monitoring stations, and official Iranian military documentation was a fully operational fleet of indigenous stealth submarines, specifically designed for operations in the shallow, thermally complex waters of the Strait of Hormuz, where American naval supremacy has been assumed as permanent condition for 4 decades. The Pentagon's response, delivered through carefully worded statements from Central Command headquarters and anonymous briefings to defense reporters, reveals an institutional assessment that borders on panic beneath the measured language of official communication. American naval planners are confronting a strategic reality that invalidates foundational assumptions about American ability to maintain freedom of navigation through the world's most critical oil transit choke point. This is not about Iranian acquisition of outdated submarine technology from external suppliers. This is not about incremental improvements to existing capabilities that American countermeasures can easily neutralize. This is about indigenous development of submarine fleet optimized specifically for the operational environment where it will be employed, incorporating design innovations that exploit known vulnerabilities in American anti-submarine warfare systems, and deployed in sufficient numbers to fundamentally alter the risk calculus for American carrier strike groups operating in confined waters where a single successful submarine attack could produce casualties exceeding any single-day loss since World War II. The implications extend far beyond regional military balance to questions about American global naval posture, the credibility of American security guarantees to Gulf allies who depend on American naval protection, and the viability of American strategic assumptions about maintaining military dominance through technological superiority when adversaries develop asymmetric capabilities specifically designed to neutralize American advantages. 3 critical questions structure the analysis that follows, and the answers determine whether American naval power retains meaningful capacity to project force in the Persian Gulf or whether the era of unchallenged American naval dominance in the region has ended permanently. First, what specific capabilities do these Iranian stealth submarines possess that distinguish them from conventional submarine threats that American anti-submarine warfare systems were designed to counter? And why do these capabilities create tactical advantages in the Strait of Hormuz that would not exist in open ocean environments? Second, how did Iranian defense industry achieve indigenous submarine development despite 4 decades of international sanctions, technology denial regimes, and isolation from global defense manufacturing networks? And what does this achievement reveal about systematic Western underestimation of Iranian technological capacity? Third, what operational options remain available to American naval commanders when the assumption that American carrier strike groups can operate in the Persian Gulf without facing credible subsurface threats has been eliminated? And how does loss of this assumption affect American ability to deter Iranian actions or reassure Gulf allies about American security commitments? The structural analysis reveals patterns that anyone familiar with how naval power shifts throughout history should recognize immediately. Dominant naval powers construct fleets optimized for projecting power across vast distances against adversaries who cannot contest control of sea lanes. These fleets become vulnerable when adversaries develop weapon systems designed not to contest sea control globally, but to deny access to specific choke points where geography constrains maneuver and where detection advantages shift from surface vessels to subsurface threats. The transition from battleship dominance to carrier dominance followed this pattern when aircraft demonstrated ability to sink battleships before battleship guns could engage. The The current transition follows identical logic as submarines demonstrate ability to threaten carriers in confined waters where carrier defensive advantages disappear. The technical specifications released by Iranian military sources describe submarine fleet designated as Qadir class, with hull dimensions of 34 meters length, 3.8 meters beam, and displacement of approximately 120 tons surfaced and 150 tons submerged. These dimensions place the vessels in the category of coastal or midget submarines, significantly smaller than conventional attack submarines operated by major naval powers. Western naval analysts initially dismissed the specifications as evidence of limited capability, assuming that small size indicated technological limitations rather than deliberate design optimization. This analysis was catastrophically wrong because it failed to understand that in the Strait of Hormuz operational environment, small size confers enormous tactical advantages that large size cannot overcome. The Strait of Hormuz measures 39 kilometers at its narrowest point with average depth of approximately 70 meters in the main shipping channel and significantly shallower depths in areas outside designated traffic lanes. The water column is characterized by complex thermal layers, high ambient noise from commercial shipping, irregular bottom topography, and restricted maneuver space that eliminates many advantages that large submarines and surface vessels possess in open ocean. In this environment, the Qadir-class design specifications represent optimization for conditions where American anti-submarine warfare systems perform poorly and where Iranian submarines gain detection advantages. The hull construction utilizes composite materials, including carbon fiber reinforced polymers, acoustic dampening coatings derived from research into metamaterial sound absorption, and geometric shaping designed to minimize acoustic signature across frequency ranges that American sonar systems employ for submarine detection. Iranian Defense Ministry technical documentation claims that the acoustic signature at 5 knots cruising speed measures below 85 decibels across the frequency spectrum from 50 to 5,000 hertz, which would place the vessels below ambient noise threshold in the high traffic environment of the Strait of Hormuz. If this specification is accurate, and American acoustic intelligence suggests it is within 10% of Iranian claims, these submarines are effectively undetectable by passive sonar when operating at low speeds in the acoustic environment of the strait. The propulsion system represents the most significant technical achievement in Iranian submarine development program. The vessels employ air-independent propulsion using fuel cell technology that allows submerged operations for up to 18 days without snorkeling or surfacing. The fuel cells use hydrogen generated through chemical reaction between sodium borohydride and water, producing electrical power that drives electric motors with minimal acoustic signature. This propulsion approach eliminates the thermal and acoustic signatures associated with diesel engines and allows extended submerged operations that conventional diesel-electric submarines cannot sustain without revealing their positions through snorkeling operations. The weapons payload includes 8 torpedo tubes arranged in 2 banks of 4, capable of launching heavyweight torpedoes with warheads of approximately 250 kilograms and effective range exceeding 15 kilometers. The torpedoes utilize wake-homing guidance systems that track the disturbed water behind moving vessels rather than requiring active acoustic homing that would reveal submarine position. Additionally, the vessels can deploy mobile mines equipped with acoustic and magnetic sensors that remain dormant on the seabed until activated by target signatures matching programmed parameters. The combination of torpedoes and mines creates layered threat that American countermeasures cannot address simultaneously. The operational concept revealed through Iranian naval exercises and official statements indicates that the submarine fleet will operate in coordinated wolf-pack tactics with individual vessels positioned at intervals along the shipping lanes through the Strait of Hormuz. The submarines remain stationary on the seabed in designated patrol zones, minimizing acoustic signature while monitoring for target vessels through passive sonar and non-acoustic sensors, including magnetic anomaly detection and thermal wake detection. When American Carrier Strike Group or commercial tanker convoy enters designated engagement zone, multiple submarines attack simultaneously from different bearings, overwhelming defensive capabilities through synchronized engagement. This operational concept exploits specific vulnerabilities in American Carrier Strike Group defensive architecture. American anti-submarine warfare depends on layers of detection, including submarine-launched sonobuoys, surface vessel towed array sonar, and helicopter-deployed dipping sonar. All of these systems perform poorly in shallow, thermally complex waters with high ambient noise. The effectiveness of American anti-submarine warfare decreases by approximately 60 to 70% in Strait of Hormuz conditions compared to open ocean environments. Iranian submarines operating in ambush mode from stationary positions gain detection advantages because they can monitor without generating acoustic signature, while American vessels must move continuously, generating noise that reveals their positions. The fleet size represents strategic commitment that Western intelligence agencies failed to anticipate despite monitoring Iranian defense industrial base for decades. Iranian sources claim 37 Qadir-class submarines are operational, with an additional 15 under construction at facilities including Bandar Abbas Shipyard, the Shahid Darvishi Naval Facility, and at least 2 underground construction facilities whose locations remain classified. If accurate, this represents submarine fleet larger than many regional naval powers and optimized for specific operational environment in ways that make direct numerical comparison to conventional submarine fleets misleading. Western intelligence failure to detect this submarine construction program until operational deployment represents catastrophic breakdown in technical intelligence collection and analysis. American reconnaissance satellites monitor Iranian coastal facilities continuously. American signals intelligence monitors Iranian military communications. American human intelligence networks inside Iran supposedly provide information about weapons development programs. Yet this submarine fleet was designed, constructed, tested, and deployed without triggering intelligence assessments that would have warned American naval planners about emerging threat requiring countermeasure development. The failure reflects systematic analytical biases that plague Western intelligence assessment of Iranian capabilities. Intelligence analysts assumed that Iranian defense industry lacked technological sophistication to develop advanced submarine systems without external assistance. They assumed that international sanctions and technology denial regimes prevented Iranian access to critical components including fuel cell systems, acoustic dampening materials, and advanced torpedoes. They assumed that Iranian statements about indigenous submarine development represented propaganda rather than accurate reporting of actual capabilities. Every assumption was wrong, and the accumulated analytical failures produced intelligence surprise comparable to Iranian ballistic missile program revelations or Iranian drone capability demonstrations. Iranian indigenous defense development has systematically exceeded Western expectations across multiple domains for 2 decades. Yet Western intelligence agencies continue operating with analytical frameworks that assume Iranian capabilities are limited by technological backwardness and isolation. This analytical framework survives despite repeated contradictions by observable reality. Iran has developed ballistic missiles with range and accuracy that Western analysts claimed were impossible without external technology transfer. Iran has produced drones with capabilities that Western analysts dismissed as exaggerated until Ukrainian battlefield evidence confirmed Iranian specifications. Iran has now demonstrated submarine technology that Western analysts are still attempting to explain away rather than accepting that Iranian defense industry has achieved genuine technological sophistication through indigenous development pathways. The question of how Iran achieved this submarine capability despite sanctions deserves detailed examination because the answer reveals fundamental flaws in Western technology denial strategies. Iranian defense industry has pursued development pathway based on academic research, commercial technology adaptation, and methodical reverse engineering of foreign systems acquired through various channels. Iranian universities produce approximately 100,000 engineering graduates annually, including specialists in materials science, naval architecture, propulsion systems, and acoustic engineering. These graduates staff defense research institutions that maintain academic academic publication records while conducting classified weapons development. The fuel cell propulsion system exemplifies this development pathway. Iranian researchers published academic papers on sodium borohydride fuel cell chemistry in international journals throughout the 2000s, while simultaneously applying the research to submarine propulsion at classified naval research facilities. The research was conducted openly because fuel cell technology has legitimate civilian applications and because Iranian researchers correctly calculated that Western intelligence agencies would not connect academic publications to submarine development programs. By the time Western analysts recognized the connection, the technology had been operationalized and deployed. The acoustic dampening materials follow similar development pattern. Iranian research institutions studying metamaterial properties for telecommunications and architectural applications published findings that had direct military applications for submarine signature reduction. The published research allowed Iranian defense engineers to develop materials with properties specifically optimized for acoustic signature management across frequencies that American sonar systems employ. The materials were tested using commercial acoustic measurement equipment that is not subject to sanctions restrictions, and then manufactured using chemical processes that Iran developed indigenously for other industrial applications. The torpedo development relied on reverse engineering of Chinese and Russian torpedoes acquired through various procurement channels combined with indigenous development of wake-homing guidance systems based on research conducted at Iranian academic institutions. The wake-homing approach was selected specifically because it requires less sophisticated sensor technology than active acoustic homing while providing effective targeting against large surface vessels creating substantial wake signatures. Iranian defense engineers correctly identified that wake-homing torpedoes optimized for attacking carriers and tankers in confined waters would be more effective than attempting to replicate sophisticated active homing systems designed for open ocean anti-submarine warfare. This development methodology reflects strategic understanding that indigenous capability does not require matching adversary technology across all domains, but rather requires developing specific capabilities optimized for specific operational requirements. Iranian submarines do not need to match American attack submarines in open ocean performance because they will never operate in open ocean environments. They need only to achieve superiority in the specific conditions of the Strait of Hormuz, where their design advantages overcome American technological sophistication in systems designed for different operational environments. The strategic implications for American naval posture in the Persian Gulf are catastrophic in ways that Pentagon officials are only beginning to acknowledge publicly. American carrier strike groups have operated in the Gulf for 4 decades with confidence that no credible subsurface threat existed. This confidence allowed aggressive posture, including positioning carriers within the Gulf itself rather than operating from standoff positions in the Arabian Sea. The positioning demonstrated American commitment to Gulf allies and provided rapid response capability to emerging crises. It also placed enormously valuable and politically sensitive assets in confined waters where they are now vulnerable to submarine attack that could produce casualties exceeding any American military loss since World War II. A single carrier houses approximately 5,000 personnel, including flight crews, maintenance specialists, and command staff. The loss of a carrier to submarine attack in the Strait of Hormuz would produce catastrophic casualties, eliminate American power projection capability in the region, and create domestic political crisis that would fundamentally reshape American Middle East policy. The probability of such loss has increased from near zero to significant single-digit percentage with deployment of Iranian submarine fleet. American naval commanders must now operate with the knowledge that every transit through the strait carries risk that was previously considered negligible. The operational constraints imposed by this threat fundamentally alter American naval posture. Carriers can no longer operate inside the Persian Gulf without accepting unacceptable risk. This forces repositioning to the Arabian Sea or the Gulf of Oman, increasing response time to regional contingencies and reducing mission effectiveness for air operations that must now cover greater distances. The repositioning also sends clear signal to regional allies that American naval presence is being constrained by Iranian capabilities, undermining confidence in American security guarantees. American anti-submarine warfare capabilities in the Strait of Hormuz are insufficient to eliminate Iranian submarine threat regardless of resources committed. The operational environment provides too many advantages to small, quiet submarines operating in ambush mode. American could deploy additional anti-submarine warfare assets, including specialized coastal patrol craft, additional helicopters, and enhanced sensor networks. These measures would increase Iranian submarine detection probability, but cannot eliminate the threat because the fundamental problem is environmental rather than technological. Shallow, noisy water with complex thermal layers and restricted maneuver space favors submarines over surface vessels regardless of technological sophistication. The only reliable American countermeasure would be sustained offensive operations against Iranian submarine fleet, including attacks on submarines at sea, strikes against submarine bases and maintenance facilities, and destruction of submarine construction infrastructure. This approach creates its own strategic problems because it requires military operations against Iranian territory that would constitute acts of war, triggering Iranian retaliation across multiple domains. American ability to conduct limited strikes without triggering broader conflict has been eroded by Iranian development of integrated deterrence architecture, including ballistic missiles, attack drones, cyber capabilities, and proxy forces positioned across the region. Regional allies are already adjusting their security calculations based on assessment that American naval dominance in the Gulf has been compromised. Saudi Arabia and the United Arab Emirates have accelerated diplomatic engagement with Iran, partly because they recognize that American military protection is no longer a reliable guarantee against Iranian capabilities. The Gulf states are repositioning oil export infrastructure to bypass the Strait of Hormuz through pipeline systems that deliver crude to Red Sea and Arabian seaports. The infrastructure investments represent tens of billions of dollars motivated by assessment that the strait can no longer be assumed as secure transit route under American protection. Insurance markets are repricing risk for tanker traffic through the strait based on assessment that submarine threat has increased substantially. Insurance premiums for strait transit have increased by approximately 30 to 40% in the 3 months since credible intelligence about Iranian submarine capabilities began circulating through Lloyd's of London and other maritime insurance centers. The premium increases reflect actuarial assessment that probability of catastrophic loss has increased even before Iranian submarines have conducted any attacks. The market signal indicates that commercial entities with financial interests in accurate risk assessment have concluded that Iranian submarine threat is real and significant. Oil markets have not yet fully priced the strategic implications of Iranian submarine fleet because most market participants do not yet understand how fundamentally the naval balance has shifted. When markets recognize that the Strait of Hormuz can no longer be assumed as reliably open under American protection, oil price implications will be substantial. Approximately 17 million barrels per day of crude oil and petroleum products transit the strait, representing approximately 20% of global oil consumption. Any sustained disruption or even credible threat of disruption would drive oil prices above $150 per barrel, with cascading economic effects across all energy-dependent industries. Iranian leverage over global oil markets has increased dramatically through submarine fleet deployment without Iran needing to actually close the strait. The credible capability to threaten closure provides bargaining power in any negotiation, while actual closure would produce economic catastrophe that might ultimately harm Iranian interests. The optimal Iranian strategy is to maintain credible threat while avoiding implementation, extracting concessions from adversaries who recognize that costs of confrontation have increased beyond acceptable levels. The Chinese strategic calculus regarding the Strait of Hormuz is evolving based on Iranian submarine revelations. China imports approximately 9 million barrels per day of crude oil, with approximately 70% transiting the strait. Chinese energy security depends on keeping the strait open, which historically aligned Chinese interests with American naval presence that guaranteed freedom of navigation. Iranian submarine fleet introduces complication because Chinese assessment may shift toward conclusion that American presence increases risk of closure by creating potential for American-Iranian confrontation that could disrupt shipping. Chinese diplomatic messaging to both Iran and the United States increasingly emphasizes Chinese interest in regional stability and freedom of navigation while carefully avoiding endorsement of American military presence as mechanism for guaranteeing access. This positioning suggests that China is preparing framework for security architecture in the Gulf that does not depend on American naval dominance, but rather on multilateral guarantees or Iranian restraint based on economic interdependence. Chinese willingness to purchase Iranian oil despite American sanctions creates economic relationship that provides China with leverage over Iranian decision-making regarding strait access. Russian interests in Iranian submarine capabilities are straightforward and aligned with broader Russian strategy of constraining American military freedom of action globally. Russian technical assistance to Iranian submarine program remains unconfirmed but highly probable given Russian interest in developing Iranian capabilities that complicate American operations. Russian naval experience with diesel-electric submarine operations in restricted waters provides expertise that Iran would find valuable, and Russian willingness to transfer technology that undermines American naval advantages has been demonstrated across multiple weapons categories. The European response has been characteristically divided between recognition that Iranian capabilities threaten European energy security and reluctance to support American military posture that Europeans assess as counterproductive escalation. European naval forces have minimal anti-submarine warfare capability in the Gulf and depend entirely on American protection for any European-flagged vessels transiting the strait. So, charter Sautins. This dependence creates European interest in negotiated solutions that reduce confrontation risk rather than military approaches that might trigger closure of shipping lanes that European economies depend upon. Israeli strategic assessment of Iranian submarines focuses less on direct threat to Israeli naval assets and more on implications for American willingness to support Israeli military operations against Iran. If American carriers cannot operate safely in the Gulf, American ability to provide air support for potential Israeli strikes against Iranian nuclear facilities is compromised. This constraint may accelerate Israeli timeline for unilateral military action based on calculation that window for operations with American support is closing as Iranian defensive capabilities improve. The submarine fleet revelation compounds other Iranian defensive improvements, including air defense systems, ballistic missile forces, and cyber capabilities that collectively create integrated deterrence architecture designed to impose costs on American military operations that American domestic politics cannot sustain. Iranian strategy is not to achieve military victory against the United States in conventional conflict, but rather to make American military operations so costly in potential casualties and economic impact that American political leadership concludes that military options are not viable for achieving political objectives. This strategy of deterrence through denial and cost imposition has proven effective across multiple domains. Iranian air defenses have improved sufficiently that American or Israeli air campaigns against Iranian nuclear facilities would require sustained operations with significant aircraft losses rather than limited strikes achieving decisive results. Iranian ballistic missile forces can strike American bases and regional allies with sufficient accuracy and volume to overwhelm missile defenses. Iranian cyber capabilities can disrupt critical infrastructure across the Gulf region and potentially extend effects to American homeland. Iranian proxy forces can attack American interests across multiple theaters simultaneously. And now Iranian submarine forces can threaten American naval assets in confined waters where American technological advantages provide insufficient protection.